Welcome to Union Theological Seminary. It's our first time doing an event here, but it's a lovely space and happy to be here. Thank you, Pamela Vreeland and Jacqueline Rabinowitz for organizing this, and Haley Martinez, who may or may not be here. Before introducing our speaker, I have to mention, because it's just too incredibly apropos, a number of you may have seen the article in the New York Times yesterday, which I'll attempt to quote as well as I can. I just scribbled a couple of notes here. A new government report came out, announced in the New York Times yesterday, saying that climate change is likely to pose a significant national security challenge in the next 2 decades. And President Obama issued a memorandum which orders federal agencies to account for climate change impacts when developing national security policy. So this is quite a significant development, and our speaker today is really one of the people who's been responsible for getting us to this point where these realities are now recognized by our president and his administration and our military. So we're very happy to have here Dr. David Titley. He asked me to keep his, abbreviate his CV, and I'll try to do that, but there's a lot of things I want to mention here so that you know who you're hearing from, because he's really quite an important person in this field. He served as a naval officer for 32 years, attaining the rank of Rear Admiral, and in that long career he served as commander of the Naval Meteorology and Oceanography Command, oceanographer and navigator of the Navy. You may not know that the nation has an oceanographer, but he was it. Deputy Assistant Chief of Naval Operations for Information Dominance as well. And he served as also Senior Military Assistant for the Director of the Office of Net Assessment and the Office of Secretary of Defense. So he's quite a highly placed person, and while still in the Pentagon, he initiated and led the U.S. Navy's Task Force on Climate Change, which, as far as I understand, was the first of its kind. So it is not inaccurate to say that Dave was possibly the first, or certainly one of the first people very high up in the U.S. military to say publicly, while still serving in the military, that climate change was a serious issue for national security and had to be treated by the military and the administration as such. So fast forward a few years, and here we are now. The president has recognized that formally. He also, after leaving the Navy, served as Deputy Undersecretary of Commerce for Operations, which is a Chief Operating Officer position at NOAA. And since a few years ago, I don't know how many, a few years, he's been at Penn State, where he's a professor of practice in meteorology and founding director of the Penn State Center for Solutions to Weather and Climate Risk. So he's got a lot of other honors. He's a fellow of the AMS and has done a lot of other things. He's led a lot of important committees. I met him recently while serving on a National Academy panel on attribution of extreme weather events to climate change, and Dave was the chair of that committee, and I had the chance to observe and admire his efficient and yet congenial and warm style of leadership, and I can see why he rose so high. Anyway, it's wonderful to have him here, and he's going to talk to us about climate change and national security, people, not polar bears. So welcome, Dr. Titley.
As mentioned, Dr. Sobel was one of the real key members. If you've seen this report, this National Academy's report on attribution of specific extreme events to climate change, it's pretty good, because we finally say, the Academy says that yes, you can for certain types of events. And Adam was an absolute key contributor to making sure that we had the science right, that we were saying everything we could without going too far, and Adam and his colleagues did an amazing job in a very short period of time. If anybody's ever worked National Academy stuff, I know that's not what we're here to talk about. Usually those are like 2-3+ year events. And with Adam's help and the other colleagues, we actually went from start to finish in just under 6 months. So we were happy about that too. Okay, so thank you very much again, Adam, for inviting me. Thanks to everyone at Columbia and the whole team who has shown such great hospitality. I've had great meetings this morning and look forward to some this afternoon. What I'm going to talk about today is really climate change as it relates to security. I've got a little bit of the science in there. My guess is many of you are studying parts of this, and you could run circles around the knowledge I have. So I'm also going to sort of talk about how I talk to this, especially to non-scientists, be they policymakers or all the way to like the Rotary Club, if you will, in a little town in Pennsylvania where, they're farmers and tons of common sense, but maybe they haven't had the opportunity for as much formal education as we all have here. So how do we talk about these complex issues which have also become political issues? Okay. So that's kind of what we're gonna do here. And let's see if I can get this to work. Yes, okay. So just a little bit about me. Any idea what this is? Yes, whoever said rain gauge, you win. Yeah, I don't know what you win, but you win. That was my pride and joy possession when I was, believe it or not, 9 years old. So yes, I am a weather geek. I was one of those kids, my mom said I hatched liking weather, probably at least since first grade. At least since first grade, I knew I was going to do weather. I had no idea it was going to be climate. I had no idea it would turn into what it's turned into. But I am, as I often say, I'm a recovering weather forecaster. And that's really, so I really approach this as a meteorologist, not honestly as a climatologist, but as a practicing meteorologist. So yes, we did that. I went to Penn State. That's not me in the lower right, but it could have been, because back when I was an undergrad, that's kind of what we did, is we hand plotted charts and we hand analyzed, did all that sort of thing. And as Adam mentioned, I ended up in the Navy. I ended up in the Navy because I went through the Navy's Reserve Officer Training Corps program, and I did that. I would love to tell you that my great-great-great-grandfather was John Paul Jones, but that's not true. I ended up in the Navy because I needed a way to pay for Penn State. I was out of state. Penn State's expensive, probably not as expensive as Columbia, but we have a lot less scholarships, so it was expensive. And the deal was, if you do ROTC, they pay your tuition, which is cool, and you owe them 4 years. So I was a great guy. I was on what I call the 4-year-and-a-day program, because I was going to give them 1 extra day. But a funny thing happened. It turns out that I actually liked going to sea and driving ships like that one and others. It's actually kind of fun driving a 100,000-ton aircraft carrier, but that's another story for another day. And the Navy thought I was at least minimally competent, so 4 years and a day turned into, well, as long as I still have fun and they don't throw me out, and that lasted for 32 years. Ended up, as Adam said, at NOAA for a little while and had the opportunity to kind of see how the Weather Service, the research component, the satellite service, the ocean service, how they all work together. Tremendous people doing tremendous things, but it's a very complex task, and knitting it all together is a continual challenge there. And now I'm at Penn State, and our tagline, if you will, is where weather and climate meet. We've got about 36 faculty, all the way from very short-range mesoscale tornadoes, tornado genesis, guys like Paul Murkowski, all the way out to, so this is a climate audience, you guys have heard of this guy named Michael Mann, probably? So he's like 4 doors down from me. And we kind of got everyone in between, and we actually think that's kind of cool. I would love to say that was a strategic plan of Penn State's, but I think it just kind of happened. But it's actually pretty good, because somehow we all talk to each other, and really that whole continuum from classic synoptic and mesoscale meteorology, but what do you do in those interannual times where you have both the climate forcing and internal variability, and how do you tease one from the other, and all the way out into the longer term climate issues. Okay, so I'm gonna kind of go through just some more basics here, a couple basics on why would we care about climate. So we all know, of course, the IPCC, AR5. So quick show of hands, who's read the whole AR5 cover to cover? Okay, I haven't either. Easier question. Who's read the entire National Climate Assessment that came in at a svelte 1,003 pages, cover to cover? Unless you're Kathy Jacobs, I'm not sure if anybody else has. Okay, I haven't either. So one of the things I learned, both by being an admiral and by working for a lot of admirals, is in general, they're not stupid people, but collectively, I would say we have the attention span of a gnat. And it kind of comes down to, unless you can boil it down to 1 or 2 slides or 1 page of paper, it's like, hey, this is too hard, give it to my staff and they'll tell me what I need to know. So, and I've also found just through the School of Hard Knocks that what do we remember? At least I can remember 3 things, but once it gets to 5, 6, 7, it gets a lot harder. But I can remember 3 things. So here's how I think of climate: people, water, and change. And it's really those 3 words. And if you think about people, it's people, not polar bears or even polar bear plunges. But why I say it's about people, it's really going to be impacting you and me and our families and the people who live in our cities and our towns, people who live in our region, people who live in other places of the world. But really, the reason I believe we should care so much about climate and climate change is because this is fundamentally a people issue. We have, roughly 8 billion on the planet right now, still going up. This is going to impact just about everyone, and it's going to impact us through food, through health, through water, energy, and it's one of, and I would argue it's not the only, but it is one of the big drivers of the 21st century. You combine that with that population increase. People in general are getting richer, so the U.S. Department of Agriculture says we're actually going to need more calories in the next 60 years than we've grown in the last 500. Put aside climate. That's a pretty big challenge right there. Globalization, whatever you think of that, the increasing sort of Moore's law, technical advances, all of this and all the budgets, we collectively tell ourselves we don't have any money in anybody's budget. All of that works together, but now we're going to do it in a world where the climate is changing. I use the water, and this is a USGS, you've probably seen this. This is the, if you took all the water, put it in a sphere, this is the fresh water, and then that little tiny dot on Atlanta, that's actually the available fresh water. But I put the water there because, and you certainly could use another integrating principle, but you think about the things that we really, really care about, the climate change, so much of it touches water. Too much, too little, wrong place, wrong time. It's salty where it used to be fresh. It's wet where it used to be dry. It's liquid where it used to be solid water. The ice is melting. Even the chemistry of the water itself in the oceans is changing thanks to the acidification. So, if you want to think of one thing that is going to impact us in so many ways, that water, it's hard to grow food without water. A tremendous amount of our energy actually uses a whole lot of water just to produce it. So I use water as kind of that integrating principle, if you will. And then I have this thing about change. And this is the part, if there's something that really scares me about the climate change, it's not the climate piece, it's the change piece. So I'm right now in central Pennsylvania. It's where I did my undergrad, and I'm back there. So I don't know, anybody's lived in Pennsylvania before? I'm sure somebody has. Okay. Between November and March, we barely see the sun. I would hardly call that an ideal climate. It's kind of cold, it's kind of gray, unless you live in San Diego, I'm not sure that you have an ideal climate. But we knew what it was, right? We knew basically when the freezes were going to come, we knew when you could safely plant, we knew what you could plant, we knew, obviously year-to-year differences, but we knew about what we were going to get. And the seas stayed about where they were. All of that stuff that we've known literally for human civilization, and I don't believe it was a coincidence that we formed human civilization when we stabilized our climate. We didn't personally do it, but the climate stabilized coming out of the ice ages. We are now embarking on changing that. So all that stuff that we have known not only from our records of 150 years, but really human memory going back to the beginning of civilization, we're going to change all that. And we're going to do it with 8 billion people. And the Treaty of Westphalia, which really kind of screws up migrations and things like that. And this globalized economy and all this stuff that hangs together. And now we're going to take the thing that we have all just kind of taken for granted. It's going to be like this, and the seas are going to be here, and I can drive past the Statue of Liberty and up the Hudson or up the East River, and I know where the ports are going to be. All of that is going to change. And that, if anything, kind of scares me, because this is hard to imagine. So, we know the 9/11 Commission, of course, talked about a failure of imagination. It's really easy to sort of have a failure of imagination for what those changes might mean for not only our civilization, but for how the world adapts. So people, water, change, and the change piece is going to be, depending on how fast we do it, it'll just be a really bumpy road. But if the climate changes faster than we can change, then this is where you start getting conflicts, especially in places that are already struggling just to do the basic things they have. Now we're going to add another part. It's like, okay, how many undergrads here? Okay, so you know, like when you're about 2 or 3 weeks behind in class, not that that's ever happened at Columbia, I'm sure, but I would get 2 or 3 weeks behind in class, and then all of a sudden the professor introduces something that like you don't even understand because you had to get that first piece, and you feel like you're now even more behind her. That's what the change is going to do to like countries that are struggling to keep up today. It's kind of like that. Okay, any idea what this thing is? I hear people mentioning, yeah, there's a few people old enough to know what this is. Sextant. And the reason I have this in here is, as Adam mentioned, I was asked by the head of the Navy, the Chief of Naval Operations back in 2009, to say, hey, Titley, take a look at this climate change, especially as it relates to the Arctic. That was really what was driving the Navy. It was the changes in the Arctic. Is this stuff real? What's going on? What should we do? Tell me. And I will freely admit, I'm on record as saying, you know, I was kind of skeptical about all this stuff maybe 8 or 9 years ago. Remember, I was a meteorologist. You see tremendous daily variability. I grew up in an era where the 3-day computer forecast, you know, was barely even worth using as cat litter. I mean, it was, you know, if I could count the number of 968, you know, nor'easter lows off of Cape Hatteras at the LFM, you guys don't even know what the LFM is, an old computer weather model had, I mean, you know, it'd be great. So I was, you know, it's like, you know, sort of think about, well, geez, if we can't get day 3 right now, tell me again why we're going to get day 50 right. So I said, okay, but let's look. So one of my honestly best jobs, my first jobs in the Navy, I got to be navigator on a really old guided missile destroyer. And about 70% of this audience is not going to believe it, but there was a time when you did not pull this thing out of your pocket and it did not tell you to within 2 meters exactly where you were on the world. You had to use something like this and shoot the stars. And what I found as navigator was, unless you wanted to find yourself working at Walmart the next week, which I did not, you look at all the data, but you don't trust any one piece of data 100%. But you look at everything, and then you kind of integrate with that stuff in between your ears to say, okay, most probably, yeah, do we have something? What do we have? How confident? Where are we going? That's kind of how you do navigation. So I kind of tried to apply that same methodology to looking at climate. It's like, okay, no suppositions, just show me the evidence. That was kind of it. I'm not going to go through all of that, believe me. That would be like a week-long thing. You guys don't need that. And honestly, probably 2/3 of the audience here knows this stuff way better than me anyways. So yes, I did start with very basic things like talking to some astrophysicists and the NASA folks, and yes, the sun was not, you know, warming up or, you know, giving us greater insulation, so okay, we can kind of check that one off the block. You know, but we start looking at these independent lines of evidence, and, you know, you have, I'm sure, just about seen all of these. You know, when you don't use arbitrary starting dates, 1998, on your global mean surface temperatures, you start seeing how, irrespective of decade, some more, some less, but we're going up, and that's surface temperatures. But say, okay, well, maybe we have biases. Maybe we're not really doing all the corrections right, because there's a bunch of corrections you have to do. We all know that here. You know, look at the sea ice extent. This is not land, but the sea ice extent in middle of the summer. And you can kind of see how that is really coming down at a pretty good clip there, about 7%, give or take. Again, ups and downs, but you can see where that's going. You know, that's independent of the surface records. Look at sea level rise, and one of the things you can look at is there is a place in Norfolk, this is on the lower left, there's a neighborhood called The Hague. This is not the Netherlands, but it's a neighborhood in Norfolk. And this shows you hours per year where they're basically flooded by the Chesapeake Bay. And it goes back, I know it's kind of hard to read in the back there, but the graph starts in 1920 and it goes till now. And I think you can see that there's a definite slope to that curve, and it's probably not even a linear slope. But you can certainly see things like hurricanes and probably nor'easters. So again, year-to-year variability, but there is a real trend there. And then finally, a graph I'm sure many have seen. This comes out of Munich Re on the lower right. So just in case people don't know, when I say Munich Re, y'all have insurance, right? You have Allstate or State Farm or USAA or MetLife or something, Geico, right? You got the whatever, for your car, for your house. The reinsurance companies insure the insurers, because if something really bad happens and they run out of money, they still have to pay policies. So they actually get insurance. And then it turns out that the reinsurance companies get insurance themselves, but we're not going to go through there. But so Munich Re, General Re, Swiss Re, those kind of companies, you know, why would you think they would care if the climate was changing? Yeah. Yeah, exactly. They need to know that because they're in the business of pricing risk, accepting risk, but then managing that. And part of the way you manage that is by pricing it right, because if you don't, you go bankrupt. And that's bad, okay? In the good, bad scheme of life, that's bad. So again, it's kind of we're not going to go through the details of the graph, but basically everything, can you see like there's this little bit of red down here at the bottom, and I'll explain what that is in a second. And you got all these other colors. So it's about 60 years worth, this is about 35 years worth of data. It starts in 1980. What Munich Re did is this is not based on population. It's not based on like value at the coast or anything. It's just big disasters, and they define what big disaster is. And it's like 1, 2, 3, whether it happened, whether it didn't. All those non-red colors are kind of weather and climate related and flooding related. And again, I would argue year-to-year variability, but those are probably going up. The thing that honestly gives me a lot of confidence in this particular data set is those red ones. They're geophysical. So like tsunamis, like volcanoes, stuff like that. And what does, for those who can see it, what does that slope of just of the red, of the lowest stuff in here, what slope does it look like we have on that one? Exactly. That's what it is. So that gives me confidence that they're not, in fact, just weighting this by population or by value, because if it was, that would probably be going up as well. So yeah, they're just counting, and what they see is the weather and climate related stuff is going up. So we've got temperatures, we've got sea ice, we've got sea level rise, or one indication of potential sea level rise. There could be a few other things like land subsidence thrown into there. And we've got just disasters counted by a company whose only intention is to stay in business and price risk correctly. They don't have a political agenda. They just have an agenda of staying in business. So that's a bunch of evidence there. I mean, I'll show you, you've probably seen, some people have seen this, but maybe not everybody. So here's another way to look at this. So NASA basically took, again, the global surface temperatures, added them up for a little over almost 30 years, 120 something years. Average, and the average is white. Blue is colder, yellows and reds are warmer. Here's the year. So these are annual averages. So this is 1950s now. And I'll run it like one more time because it's really cool to kind of watch the Dust Bowl, because we think of the Dust Bowl as super, super hot. You know, it's like, well, geez, we've been at these temperatures before. Here's the 70s when it was supposed to be cold, and it was cold in places. The 80s, the 90s. Y2K, we made it, for those of you who remember that. And there's 2012, and I need to update this, I know. I'll run it one more time, and you can either just pick a spot, or you can kind of watch, maybe like if your parents emigrated a few generations ago or whatever, you can kind of watch this. I like this because it shows not only the internal variability, the splotchiness, if you will, and that time variance, but over time you start to see how you can almost think of those as like waves coming in on the shore, but the tide is coming up, and that's sort of the climate signal. So again, we went through the Dust Bowl. It was pretty warm in parts of the U.S., but there were lots of parts of the world that were actually cooler than the average. So again, 70s, 80s, 90s. And again, this is, I tell people, like when I'm talking to either policymakers or even just the general public, this is not a projection. This is not somebody with a computer model saying, well, this might happen someday. This is what we've already seen. This is just what we've already seen in the world. So that's sometimes when you're communicating about this stuff is useful, that you're trying to show people that the climate is already changing. This isn't something that, well, maybe in the 22nd century we'll have to worry about, but the changes are already well underway. And I'll show you another one. This is my last animation on this. So this comes from my friends at NOAA. And just to orient you, so we're looking down on the pole. So Alaska's at the 4 o'clock position. Russia kind of from 9 all the way to midnight. Scandinavia at like 2 a.m. Greenland at 4. So what we're seeing here is the year is down on the lower center here. And then the months, and you can see it scrolling by. This is, and again, I'm sure most of you know this, but this is not visible imagery, but it's actually microwave. So you can look through the night, you can look through the clouds. That's really good stuff to do. The even cooler part about this imagery is you get a different return depending on what kind of ice you have. So the old, hard, thick ice, what we call multi-year ice, you get a different return, and NOAA has very kindly colored that to be white. It looks really hard. And the blue stuff is the much newer ice. So we'll run it, one more time. And this is really what got the Navy so interested in the whole climate thing. So, and if you're a science geek like me, and I'm sure like a number of you, this is just fascinating. You can see the gyres, you can see that counterclockwise circulation. You watch the advection through the Friem Strait. Watch what happens in 07. So it's 2005, 2006. 7, wham, the ice goes away, tries to come back, like my portfolio tried to in 2008. And in 2012, again, it collapsed. Now, if I had 13 and 14, it tries to come back. But, this year, I think we're number 2 or number 3 lowest ever, again. We just got to minimum ice here about a week ago or so. So, again, this is what's happened. And I tell people that, this change in roughly 15 years is what, if you had asked most scientists, let's say in the early 90s or even early 2000s, it's like, yes, the Arctic ice will probably come out, but it's going to happen middle to the end of the century. And instead, we have gone from a regime where it was, 60+% multi-year ice to now only maybe 15% multi-year ice. So it still freezes up in the winter, but it's much thinner, much more dynamic, much more prone to fracturing and stressing, and there's all kinds of downstream consequences for that. Again, so there's sort of evidence, if you will. So I get to all of that. We'll go through this pretty quickly. You probably heard of the guy Hansen, right? Jim Hansen. My guess is up here you would have. Not the Muppets guy. So on the top there, that came out of a science magazine, and if it looks like a PDF of Xerox of a PDF of a Xerox, it's because it is. It's old. It's like I think it was 1979 or 1980. So we now have, so again, Hansen ran that on probably less computing power than, again, we all have in our phones. But the black lines on that top graph, he had to make some assumptions on what the atmosphere would look like. And then the magenta line, long story short, is basically what the observations showed. So I tell, again, if I'm talking to, especially policymakers, and they like to sometimes, get into this mano a mano thing about models. And it says, well, here's a thing to remember, and it comes from a British statistician, Box, that all models are wrong, but some are useful. So I would argue that while Hansen may have been technically wrong, he was actually conservative in this particular one, too cold. It was very useful because he basically said, guys and gals, we're about to get on an escalator, and we're about to start going up. And sure enough, that's about what happened. And again, if you look at, the AR, I think this was 3, if I'm not mistaken, AR 3, I think. So those came out at about the year 2000. I have had some people say, the models aren't doing any good. Well, that's up through 2015. 2016 would actually be just above that black line, most likely. So again, within the natural variability, which is not really captured explicitly in these climate models, by and large, we're doing pretty good. So we have a ton of observations. We can actually model this stuff. We can, in fact, predict it. So, what I tell people is, oh, by the way, Exxon and Esso, they were able to come up with the same answers in 1980 as the publicly funded science did, but what they did with them maybe is another discussion for another time. Why can we do that? And I would have fellow admirals and generals in the Pentagon say, my God, Titley, what happened? Did you get, some kind of crazy religion or something? And I said, no, I just went to the Church of the Radiative Transfer Equation, which is what that is, because it's really just physics. And not only is it physics, but I tell people it's cutting-edge 19th century physics. So you have these old guys here, Fourier, Tyndall, Arnhus, so you had a Frenchman, a Scot, a Swede. They did not go into a bar, by the way. But they, starting in 1842 and ending up roughly around the turn of the 20th century, we had figured out all the way from the basic molecular reason why some gases re-radiate the heat, they're greenhouse gases, all the way to, Arnhus with literally a pencil and, stubby pencil and paper, starting to do some greenhouse gas calculations and climate change calculations based on the first part of the Industrial Revolution. So, I try to stress to people that the basics of this climate change, it doesn't matter whether it's 96 or 97 or 98%. I mean, this is kind of like arguing about gravity. We have known the basic physical causes for way over 100 years. Now, the even more interesting story, if you ever get to hear John Holdren, he talks about the history of climate change. We figured all this stuff out in the 19th century. The first part of the 20th century, there were actually a number of pretty good scientists who really thought that the ocean was simply going to absorb all the CO2 and this wasn't going to be an issue. And basically by the middle of about 1950, we figured out that wasn't true. Guys like Revell, like Keeling and stuff like that. And pretty much ever since the end of World War II, we came back to these guys and said, yeah, this is what's going on. So I try to tell people that, the ICE doesn't see this as a political issue. The ICE doesn't care whether people vote or whatever. The ICE just melts according to these equations. And what we do is, we'll see, but the ICE doesn't care. It's just going to obey the laws of physics. And we understand those laws. I mean, we have understood them for many, many, many decades. There just isn't a controversy in that. Okay, so this is the part where, I'd ask, I've gone through the evidence, and here, so who believes in climate change? And I don't just mean like that kind of belief. I mean, who believes in climate change here? So show of hands, who believes in climate change? You see, I don't. I know, cheap rhetorical trick, I'm sorry. And the reason I say that is I don't see climate as a belief system. It's evidence, okay? I am convinced by the overwhelming weight of evidence that the climate is certainly changing. It's absolutely changing. But belief systems, maybe that's something we do Friday night or Saturday night or Sunday morning. Those are kind of belief systems. We have a lot of belief systems. I have a belief in America as a preeminent country in the world, and we still look for leadership. That's a belief of mine. But as far as climate, I really see this is really based on evidence. So, we all probably get the question as soon as you find out you're somewhere connected to this field. Oh, do you believe in climate change or not? I said, well, that's a lousy question. Depends who asks it, whether I tell them it's a lousy question or not. But it's really, it's evidence. It's an evidence-based thing, not a belief. Okay, we don't have time for this, but I, could play for you my little clip with the good Senator Cruz when I got to testify before him back in December. I was explaining to Senator Cruz that, a few satellite observations with poor corrections do not, in fact, invalidate 150 years of science. He didn't buy it, but that's okay. And, I'm sure you know the gentleman down here, Dan Kahan out at Yale and Kahneman at Princeton. Really the psychology of how we talk about this. I think ultimately it's going to be as much or more the psychologist and the social scientist who help us really communicate this issue, because the physical scientist, it's like, duh, guys, I've just gone through all of that. And people who get it, but there's a lot of folks who, those arguments sometimes resonate, but they sometimes don't. So when you're talking to the public, you sort of got to figure out what resonates, but even when you're talking about sort of this stuff back in here, the simpler you can keep your language, sort of like de-jargonify it, that's a terrible word, isn't it? De-jargonize it wherever you can, because it's so easy for us to all sort of start slipping into our the speak that we would use or the language we would use when talking to fellow colleagues. And it turns out that just wham, it goes right across people's heads. Okay, let's talk about climate as a security risk. So as Adam mentioned, yesterday the president actually signed out what they call a presidential memorandum that basically tells the federal government writ large is, hey, you guys need to really be thinking about climate as a security issue in everything you do. There's a whole bunch of stuff. And then there's working groups and there's all this kind of stuff. But the top line of what the president is directing the federal government to do is you really need to be thinking about climate as a security risk. So I was very, very happy to see that. So one of the things I've said, Adam's probably tired of me saying this, he's heard it a lot, but we plan for climate, but we live in weather. And that's sort of one of the ways we put this together. And this, I stole this slide that Joint Chiefs of Staff would roll over in their graves if they knew I was using one of their planning slides for a climate change talk. But if you kind of look at this, the left-hand side, you can just sort of read what's on here. Those are planning things. The right-hand side is execution. So it's kind of like the left-hand side is like that's how you would think about climate. The right-hand side is now we're going to do something, and now our focus is how good are we at weather? How good are we at predicting the extreme weather events? Do we anticipate them? Do we have plans to recover from them? Can we exploit them? But that's sort of how weather and climate sort of would be thought of in a whole, if you will, sort of using what is the U.S. military's joint doctrine, if you will, at a high level. This is a slide, or basically a version of a slide I gave a couple of years ago at Newport. So about every 2 years, the United States Navy, we basically invite all of our friends, so about 70, 75 heads of navies of everywhere from Britain to Zimbabwe and everybody in between. And I was asked by the then Chief of Naval Operations, a guy named John Greenert, to basically lead that group in a morning of talking about climate change as a naval risk, as a military risk. So this was one of my key slides, because it's like, I did a little bit of the science, but honestly they weren't all that interested in the science, and they're not interested in sort of like all this stuff. It's like Navy people by and large are kind of pragmatic. And it's like, okay, Titley, fine. Tell me specifically why should I care about climate and how does it impact my mission? So the things that we're going to be impacted are down here on the left, and then the way it's going to impact the militaries and navies in particular are the column headings. So one of the things you might notice about this slide is the only place I even use the word climate is actually up in the title. But this is, again, sort of that concept of, talk in their language, not yours. So again, this was to a bunch of senior military professionals. Everybody understands in that room, everybody understood what capacity is. Readiness. Readiness means not only do you have tanks and fighter aircraft and cool ships, but you also have people who know how to use them, maintain them, and use them. That's a ready force. It's one thing to have all these cool things and have a whole bunch of people, but if the people can't execute and execute under stress using the technology and the tools, then they're really not a ready force. So any first-line military not only wants enough capacity, but they want to be ready. And then new missions is, of course, just what it sounds. So I'll go through a couple of examples here in the slides, but the Arctic is, as we've already shown, is opening up. That lends to a whole new set of missions. Surface ships are going to go where they literally have not gone before. Not to sound too Star Trek-like, but that's what's going to happen. Why do we care about bases? Bases in the United States and in many countries are where you generate readiness. So the American way of war, as we probably all know here, is we don't fight the home game. We don't want to fight the home game. We tried that in 9/11. We don't like that. We want to fight the away game. We want to fight, if we have to fight, we want to fight over there. But again, you need ready forces. So where do we generate that readiness? We do that at our bases, be it Norfolk Naval Base, be it Fort Bliss for the Army, be it Langley for the Air Force. That's where we make sure that our soldiers, sailors, airmen, and Marines, they become frankly, the world's preeminent fighting force. Disaster relief, you see that, big hurricane, big typhoon, that's where the militaries do this. We can actually do that mission really well, but the question becomes, if you keep doing that more and more and more, what else are you going to start not doing? And then the security threats, I'll talk about that, and again, some of your colleagues here, your faculty, like their writings on Syria, their research on Syria, really is some of the basis of how I use and what I think about this. So, okay, we've talked about the Arctic just a little bit, and again, these are just snapshots out of that animation that I showed you. So you can see from 1990 to, fast forward, 26 years, how that multi-year ice has sort of collapsed in the Arctic. But again, three things. Remember, I can only remember three things. So the Arctic is changing. We've seen that. It's not a vacuum, and what I mean by that is both physically, and we've seen, of course, a lot of cutting-edge research on how much of a change in the Arctic and the ice conditions actually may impact the weather that we have here, like in the Northeast, in New York City, and other places. So how much does that feed in? It's also true on a geopolitical sense. So we see, Putin, of course, went into Crimea, then Ukraine. The West, led by America primarily, put sanctions on. Putin said, okay, I'll start increasing my forces in the Arctic. So you start getting geopolitical tensions or crises that happen in the middle latitudes, let's say in Eastern Europe or Central Europe, get reflected in the security posture up in the Arctic. And then it's time to get ready. And the reason for that is, even though no people are not just sailing across the top of the Arctic Ocean in container vessels right now, it's time to get ready, because by the time you finally get surface ships that could operate up there, that's going to take at least a decade, at least, probably more like 15 years, because of the way we do our buying of ships. So you got to sort of, shoot ahead of the rabbit, if you will. I owned rabbits for 20 years, and my wife hates it when I use that phrase. But you gotta anticipate. So that's really what we've got to do. And again, it's about access, and it's honestly about sovereignty. We are an Arctic nation, although we forget it. Okay, so we'll keep going here. So the Navy has, I would say, been interested in the Arctic on an episodic basis. And that is not a slam on the Navy, but the Navy is interested in a place when it sees it in their interest to be interested, if that makes sense. That's why. So all the way from, we obviously fought part of World War II up there. The Japanese invaded U.S. sovereign territory, some of the Aleutian Islands. Post-World War II, we were involved in a lot of the DEW line, basically the missile defense warning against the then Soviet Union. I was up in the Aleutians in January in the 1980s. We were basically showing the Soviets at the time that we could operate in their kind of conditions any time of the year. That was fun. They got great sea stories about that. Take a 40,000-ton ship and start rolling at 40 degrees. That's exciting. And all the way. You can see that. So why is the Navy interested now, or at least to some degree? It's because they see these changes, and they see that shipping routes are going to go. They see increasing human activity. We don't know in 20 years, let alone 30 years, who's going to be our friend, who's going to be our adversary, who's going to be, we're sort of in this kind of like, where I'm watching you and you're watching me. But we do know that if the president, if he or she at that point says, hey, Navy, I want to make sure that I can either protect shipping, project power, do whatever it is navies do, turning around and saying, Madam President, I'm really sorry, but back in the year 2015, we just kind of blew this off, so now we don't have any capability. That would not be a place you'd want to be. So this is why we need to be thinking about it now, and it's why the Navy is thinking about it. It takes time to get ready. And there's all kinds of basic things. We really, I guess the technical term would be suck at weather forecasting up there right now. We have grossly inadequate charts. We have precious little infrastructure. Who's been up in the Arctic? Okay, a few. Yeah, there ain't much up there, right? I mean, there just ain't much up there. I mean, who's eating at Pepe's, right? In Barrow. Yeah, $50 pizza, that was good. So there's not much up there. And you can operate that way, but it's a very austere environment. It's still hazardous. It's still dark. Whatever the climate does, it's still going to be dark half the year. It's still going to be bad weather. In fact, in some ways, the weather gets worse because on these ships, if you have more open water, you get the storms. And who's seen Deadliest Catch? Okay, admit it. Okay, yeah. So what happens in the wintertime is you start getting the spray, and the spray freezes on the ship. And the U.S. Navy's really high-tech way of removing ice? Yeah, 19-year-old seaman out there with a mallet. It hasn't really changed much in the last 150 years. So we've got to think about that. And the way you get used to this kind of stuff is by doing. I mean, it's like almost anything else in life. You have to gain experience and expertise and learn those lessons and do them enough so that they become institutionalized, because it is a different environment. And if you don't work in that, you're going to have a hard time. So, okay, I'll get off my diatribe on why the Navy needs to do this. The current head of the Navy, a guy named John Richardson, Admiral John Richardson, he recognizes this, but he also feels very pressured by all the other day-to-day demands, be it in the South China Sea, be it with the dear leader up in North Korea, be it with the whole Iranian thing in the Persian Gulf. And the number of ships the U.S. Navy has keeps going down, down, down. So he says, yeah, I would love to be training up here, but I'm out of Schlitz. That's a New York beer, so you guys should know that one. It's, I'm just out of resources. But so they see it as a problem. They're probably not doing as much as they need to. Okay, this is, this comes out of the U.S. Navy's Arctic Roadmap. So I put the first one out in 2009, and we said it was going to get updated in 5 years. And miracle of bureaucratic miracles, it actually got updated in 5 years, which never happens because, who's had to either write or use or read about a living document? Okay, that's usually the kiss of death, right? It's like, yeah, it's living all right. So this one actually kind of did. And the interesting thing is, again, this is the U.S. Navy's projection, not mine or some, random scientist that I found. But the Navy is projecting this green route, basically this over-the-top transpolar route, starting to open up in the mid-2020s, basically in a decade from now. Are they going to be right or wrong? We'll see. But they're basically saying that could be used. Now, 2 weeks, honestly, is not going to change global shipping routes. But when you start getting about 8 weeks of pretty much guaranteed open water passage, you will likely see shipping routes start to change. And that's kind of, and security forces better be ready for that because the commercial guys are going to come. And that's kind of what we need to watch. Here's a piece of the Arctic that we don't always think about. So I've talked a lot about sort of U.S. kind of centric. Anyone been to Svalbard? Somebody? Nope? Okay, Svalbard, really, really kind of cool place. So we all know where Norway is. Get on an airplane in Oslo, fly it due north for about 2.5 hours, and you end up in Svalbard. It's this relatively small island. This is not the best graph in the world. Here's Greenland, if you can see that. Svalbard is basically off the northeast coast of Greenland. It's up at 79, 80 degrees north. And it's Norwegian territory mostly. There's something called the Treaty of Svalbard, signed in the 1920s. It's a sort of relic out of World War I, believe it or not, that mostly gives this to the Norwegians. The Norwegians, if they were here, would say it is Norwegian sovereign territory. But anybody who signed the treaty can basically build a base there for research. You can imagine what kind of research the Chinese and the Russians are doing there. One of the really cool things about Svalbard, this is not like episode 2 of Star Wars, but you are so far north, you capture every single polar orbiting orbit, every one. Even in Fairbanks, we can't do that. Fairbanks, Alaska, we're not far enough north. Here you get them every one. So about every 106 or 108 minutes, you can talk to that satellite, you can control that satellite, it can talk to you, every polar orbiter. So you think that's strategic? That's pretty strategic. And they have the infrastructure, and they have very high broadband. In fact, the internet worked better in Svalbard than it usually does in my house. Down into Europe, they got a trained workforce. So this is a pretty, like, if you want to control the strategic high ground of space, Svalbard is a pretty interesting island. Now, I bring up all that geopolitical stuff. Oh, by the way, you haven't lived. Any political scientist here? Okay, a few. Okay, I won't make too much fun of you guys. But it was really fun trying to explain to a busload of historians and political scientists why you couldn't just move Svalbard to Singapore and you wouldn't be able to control the satellites just the same way. So I'm trying to like show how the Earth is changing and the satellites are going around, and it's like, and you're drawing this in the bus as you're going up a mountain. It was a lot of fun. I think they got it though. So the reason we talk about Svalbard though with this treaty is who owns the waters around Svalbard is honestly not too clear. So most nations have something what they call an exclusive economic zone. It's well recognized in the UNCLOS and Law of the Sea Treaty. The Norwegians call the area around Svalbard a fisheries protection zone. And what they mean by that is, well, we don't really want to call it an exclusive economic zone. The Russians don't really recognize this. So a week after we were there, the Russians have their deputy prime minister just show up in Svalbard. And you know how the Norwegians found out about it? Watching TV. So, and then the Norwegians kind of asked the Russians, so hey, dudes, like, what are you doing? And they said, we're doing whatever we want to. Watch us. So is this Norwegian territory or whose territory? And, you know, so Norway's part of NATO, right? And NATO has one of these things called Article 5, an attack on one is an attack on all. What if the Russians really started pushing? What would the US response be if they started pushing on Svalbard? Would we say that's really Norwegian territory, or would we say, you know, that's not really Norwegian territory? Do the Norwegians know what we would do if they got pushed so that they don't get themselves too far out? So I've asked the State Department to just think about those. I'm not sure what the answers are, but this is a place where in the Arctic those geopolitical tensions can come together on a very strategic piece of land that I would say 98% of Americans have never heard of before. So, okay, I'll get off my Arctic kick here, but in addition to thinking about the Bering Strait and the ice and all the normal things, there's some very interesting U.S. equities, whether we realize we have them or not, on the other side of the Arctic here with some very good friends. Okay, sea level rise. We think about sea level rise, and, you know, especially periodically in the COPs, it shows up. You know, we had Tuvalu, we had the islands in the Paris COP here just last December. We've all seen, you know, how much low-lying areas in Bangladesh, and these are huge issues. And, you know, especially if you look at where the ice stabilizes, these are really big issues. But here's a couple issues more in a defense realm. So any idea what this island is on the left? Anyone know where that is? A place called Diego Garcia. And it is British Indian Ocean territory. The Brits actually own it, but as long as we're nice to the fishes and the reefs and the critters, the US military can do just about anything it wants. And anything it wants means that island has supported every significant operation we've done in the Middle East, Persian Gulf area since the 70s. And it's only about 1.5 meters to 2 meters above sea level. So I have asked the DoD, it's like, you know, you might want to make sure your tide gauges are working there and that you have good long-term records, because, you know, there's a lot of local variations in the effective rise of sea level. It depends on a number of factors. But I'd make sure I knew how long I had that island for, because if it goes away, we change the concept of operations for pretty much how we do everything in that part of the world. That would be a big deal. The picture on the right, this is what happens when maybe it's no good deed goes unpunished. U.S. Navy knew there was a hurricane. I think this was Isabel coming up to Norfolk. They evacuated the ships to make sure they're not hurt. The sailors come down to evacuate the ships, and they park their cars in the normal parking lot that they parked in, and they were not happy when they got back. So call it nuisance flooding, call it what else, but I'll tell you, if you owned one of those cars, it's a lot more than nuisance flooding there. And as the sea levels rise, as we all know, I think in this room, it takes less and less and less of a storm to do this until eventually, it's still decades out, but eventually that's going to be a normal day for that parking lot if we don't do anything. It's not just a Norfolk issue. We always think of Norfolk, we think of Miami, we think of, sometimes these other strategic places. So I was in Norway talking about Arctic stuff at a climate thing, and we had a morning off on a Saturday, and this is in Bergen, Norway. Just a normal day, not even particularly interesting weather, just regular kind of November day. If you go to Norway in November, your boss knows it's not a junket because nobody would go to Norway in November. And you can see where the water is already coming up. So everybody who has a coast, just about, is going to deal with the sea level rise. And the reason I bring that up is we think of all the other things we're going to need to do. The money it's going to take to do something, be it harden, be it move, be it do something, is going to compete with all those other things we thought we were going to do. Okay, we know how many people are within high tide. The geostrategic risk. I mean, we've got Richard and Mark probably either here. They've literally written the papers on this. So you have the experts actually here at Columbia that talk about these. But long story short, it's really the climate forcing of the drought was one of the links in a chain of events. And when I talk especially to policymakers and Department of Defense officials, most of them at some time have been involved in what we call mishap investigations or accident investigations. And almost always, like on a modern jetliner, they're so reliable nowadays. It's so rare that it's just like, hey, this thing failed and that's why it fell out of the sky. It's usually A and B and C and D and E. And that's kind of how the drought fits into Syria. All the way from Assad making policy decisions back in the 70s to be food self-sufficient, draining the aquifers, using the water. He made it. But then when you start getting some of these climate magnified and intensified droughts, in addition to all the other things, like 1 million refugees from the Iraq War, now 750,000 internally displaced persons, and you have a government who fundamentally is not taking care of the populace, okay? Then you have these catastrophic conditions where extremism can be very, very easy to take hold, and you get things like ISIS, like ISIL. So it's not that we can say that climate caused ISIL. That's not what I'm saying. But I'm also push back hard against people who say there's no link between the climate and the geopolitical threat. It's in the middle. I hope that makes sense because people want to keep simplifying it, and unfortunately, the simplest I can make this is it's one link in a chain of events, but the fact that that link was there and not broken allowed that to its ultimate catastrophic outcome. Same kind of story with Syria. If there's Q&A or you're interested, we can talk about that as well. Just a few things here, and I'm probably not going to go through the energy stuff in the interest of time, but just about everything that we're going to do on this, leadership really does count. The only reason that I did what I was able to do in the Navy on Task Force Climate Change is that guy on the top right, he was the Chief of Naval Operations, he was the head dude, he said, we need to look at this. And the Navy knew that the head guy was interested. And there's a saying I always use is, if your boss is interested, you're fascinated. It doesn't work so well in academia, but in most places it does. It works especially well in a hierarchical organization like the military. They knew the boss was interested. I just got to do the fun stuff. But because of his leadership, that's where we are. Because of the Secretary of the Navy's leadership, the Navy's done a lot of stuff on energy and innovative energy. The other part is you're not going to solve these very complex issues by yourselves. So on the bottom left, we have something called the Arctic Security Forces Roundtable. Basically, the militaries from each Arctic nation get together at the same place at the same time. We started this in 2011. To talk about military issues. It turns out the Arctic Council, by its charter, does not talk about security, and that was intentional. So we needed to kind of form an organization that could, outside the council, and we have one. My task force climate change, or what was my task force climate change, people thought, oh, you're an admiral, you're in the military, you must have thousands of people working on this. It's like, yeah, I wish. I had about 2.5 people. One of those people, some of you might know, Courtney St. John. She actually then came to the Center for CRED, but I'm going to mess up the acronym there. Environmental Decisions, right? And I'm apologize. Sometimes it's bad when you get old. But Courtney came up here, and I had 2 officers, and that was about it. But what we did have is we had pretty much from every one of those logos interest, and people would work with us, not for us, but with us. And when you can form these kinds of teams, you can get so much more done than if you're just trying to do it yourself. So leadership and teamwork are really, really important for how we go forward here. There's a ton of sort of technical solutions all the way from what they're trying to do down in the Hampton Roads, Norfolk area. You can pick up almost any version of The Economist, and there's some cool Silicon Valley companies doing, food that doesn't use greenhouse, that doesn't use animals but tastes better than meat and all this kind of stuff. On the technical side, there is a program called Earth System Prediction Capability. It's funded by the Department of Defense, looking at how do we improve forecasts from 0 hours out to 30 years. So we got the money for that starting in about 2013. There is a Senate bill that is now directing NOAA to play nice with this program. So we're trying to couple up our military and our civilian capabilities to through the help of the Congress to knit that. There's risk management up at the top. We kind of know how to do this. The hard part is doing it. But there are solutions here, and of course, ultimately I've talked about that, the decarbonizing. These are just some recommendations for the Arctic. We'll keep going on that. I've talked about that. So I'm going to save this one. If people are interested in Q&A, you can ask me about why do I have a llama in my brief. But there is a reason I have a llama. And the punchline is, how do you go viral on the internet? Cats, right? Cute cats. I have no cute cats, but I do have a llama, and if anybody's interested in Q&A, I'll tell you what it stands for there. Okay, here's, I think, some really encouraging news, although it sometimes gets lost in the political conflict, is there are, what do I have on here, about 8 vectors, I think. Everybody, kind of if they're working in their lane, so you align message and messenger, coming at it from very different aspects, but we're coming to a common conclusion that climate is a risk. So, I'm kind of down here at the 6 o'clock position. I tend to, try to stay in my lane of talking about climate as a security risk, and I think it is, and the president now agrees, and that's all good. Guys like James Balog, so involving the media, and there's a number of other films on climate. How do they tell a story? The environmentalist, okay, I do have my polar bear on the ice, and to their credit, for decades, they have tried to raise awareness on this issue. The left one is risky business, so Hank Paulson and Bloomberg. So Paulson talks about this as being the Secretary of Treasury during the housing collapse, and he says, hey, I know bubbles. And he says, I don't say I'm a physical scientist, but I know bubbles, and I see a climate bubble for the investment community. So he talks to big investors. The Pope, of course, but other religious groups have talked very convincingly on a moral case, if that is what appeals to people. The insurance guys, divestment, the health. So everybody kind of in their same, coming from their perspective, all say, you know, we really need to seriously address this issue, and ultimately we're going to have to adapt for the changes that are coming, but we're going to have to ultimately decarbonize our energy structure. And I think that is helpful because we see, I mean, you know, variability in the polls, but more and more people are understanding this message here. Okay, again, in the interest of time, I'm not going to be able to go through the carbon, but you know, while we have good acceleration in non-carbon based, we're not there. We still have a long, long ways to go. Here's kind of the one slide I'll just talk about for a second. We've already, in the history of this country, gone through 2 or 3 energy revolutions. You know, when the country was formed, we were 100% wood, and then we went to coal, and then we went to oil and gas. You know, so as we get to renewables and non-carbon, you know, at what, I mean, we're going to get there, but at what rate? Are government policies going to accelerate that transition or retard that transition? And how fast do we get there? There are a number of very real technical issues on how many renewables, intermittent renewables, you can add to a grid before you got to start doing other things. And actually some economists in the Columbia Business School have put some nice work out on how to think about that. I say follow the money. This is, and many of you have probably seen this, but this is basically what the US spends in non-defense research and development. Yellow is space. It's pretty easy to see on there where President Kennedy said, hey guys, we're going to go to the moon and come back and we're going to do it in a decade. Boom. The money goes from, you know, a few billion a year to roughly 35 or 40 billion a year. You can even see the Arab oil crises of 73 and 79 in here. That green is energy. I would point to this sort of in the last 10 or 15 years, and it's really hard for me to see where we ever really got very serious about these climate issues. So we have a lot of rhetoric, a lot of talk, but we don't reflect it in the budget. Now, I know there's private sector money, but there are still big things in storage and transport and smart grids and all that sort of thing that we need to do. And yes, there's been a little money, but this is kind of where our priorities are. I've told a few people this morning, you know, I spent too much time in Washington, and you are your budget. And my budget, if I came in from Mars and looked at this, I would not know that we are facing an existential climate problem because there's really no change in investment. Okay. There certainly will be surprises. You know, Niels Bohr, you know, said predictions are tough, especially about the future. What is the future of climate intervention? The less scary side of carbon dioxide removal, or the really scary side of albedo modification. As we keep changing the climate, and depending on how fast we do or do not decarbonize ourselves, where does that go? Not only in the US, but in other places. Understanding, you know, there's still fundamentals to understand about aerosols, there's still fundamentals to understand about the deep ocean, and of course, you know, trying to understand sort of, I'll call them tactical issues on like interplay between the Arctic and mid-latitude weather. You probably know all this, but you know, the risk, it's not a normal distribution curve. We have a fat tail risk in climate, and the fat tails are the ones that should scare us. How fast does the Antarctic ice sheets come off? How fast does Greenland come off? How fast do we get to 1, 2, 3 meters of sea level rise? And what are we going to do from that? Here's just a couple of quotes I usually use because I don't think either Admiral Nimitz or George Shultz are really known as environmental tree huggers. I could be wrong, but I don't think so. And Admiral Nimitz was not talking about climate change specifically, but those are his words after Admiral Halsey drove through a typhoon in December 1944, sunk 3 US Navy ships and killed over 700 sailors. It was actually the worst loss the US Navy had taken since Pearl Harbor when he went through that. And I think you could, though, put climate in there. Nothing is more dangerous than grudgingly preparing for taking precautions, let's say, turned out to be unnecessary. And same thing that Secretary Shultz said, and that was regarding President Reagan's philosophy on the ozone hole. Okay, If anybody ever wants to sort of, I've talked all this high-level stuff, I'll just show sort of a personal example. This is the house I used to live in when I was running the Navy's Operational Weather and Ocean program. This was in a place called Waveland, Mississippi. So we were like 3 houses up from the beach. And this is what the house looks like after a 9-meter storm surge goes through. So when we say we lost our house, we actually did lose it, because to this day we have no idea where the house is. It either went up in the railway tracks, which is that way, or it got sucked out into the Gulf, which is that way. But when we first got back a few days later, the lot was as clear as you see it. So now the good thing is the ugliest house on the street was the one up from us. So I'm sort of comforted that mine came off its foundations, knocked down the ugly house, and that's okay. That's actually okay. Don't feel sorry for us. We had insurance. So many people did not. And our stuff wasn't in it. Our stuff was in a moving van coming here. It's a long story. I don't have time for that. We were the luckiest people on the Gulf Coast. So I don't show this for pity, but think of the people not only in the U.S., but around the world who will be dealing with this kind of storm surge because it's coming in on a higher and higher baseline. And if they're not prepared, and most people are not, what are they going to do? And if you have enough people who have nothing, and the governments don't take care of them, and societies don't take care of them, that can become a security issue, not to mention a moral issue and social issue and all those other things. Yeah, this is just sort of my editorial comment on how we do adaptation today. My lot is the one with the for sale sign. See me afterwards, I can give you a good deal. Our neighbors to the left, they rebuilt at exactly the same elevation they were before, because this is never going to happen again. And then the guy on the far left, he was the neighborhood plumber. Mama didn't raise no fool. He's up at about 10 meters. I hate to tell him what those little skinny pylons are going to do when you start getting 5, 6, 7 meter per second storm surge coming through with a debris field, but he thinks he's doing okay. So this is, we all think of Mississippi as living in the past. I would argue it's actually living in the future. This is what adaptation looks like with no policy. Every person for themselves. Okay, why do I have Churchill? Churchill is alleged to have said, it turns out he didn't say anything, but he's alleged to have said a lot of stuff, that Americans can always be counted upon to do the right thing after exhausting every other possibility. So I think we're sort of in that exhausting stage. Hopefully we're getting towards the end, and we will get on to do the right thing. I've talked about beliefs and evidence before, and I kind of led with one of my beliefs, which is that America really, from what I see in my world travels, is that the world still does look to America for leadership. What we do counts. It counts at home, but it counts as abroad. And we know that when we get focused, we can do absolutely amazing things. We have to get focused. I mean, so this comes out of course, the Tom Hanks Apollo 13 movie. The more you read the actual history, I mean, those astronauts really should have been dead. There is no way we should have been able to get them home, but we did. We put incredible ingenuity together. Now, it's a very tactical problem, but we did amazing things, and I think we can scale that up, and America can lead the way, and I think we will. I'm not sure when, and I'm not sure what events will have to happen to make that happen, but when we get focused, we still are the preeminent country. So I will stop there. I apologize for the length, but thank you very much. I'm happy to take any questions if there is time for that. Thank you. So this was kind of fun. So we took an airplane from Washington to Anchorage to Barrow, get on a Twin Otter, it lands on the ice, get on a helicopter, and in a 20-hour travel, we made it with about 10 minutes to spare to see the submarine come up through the ice. But as we're there, the guy who's sort of doing the safety brief, who says, okay, the sub's supposed to come up here. But if you hear the ice crack under you, this is the direction we're going to run. And at that point, you realize that you're standing on maybe, 1.5 meters of ice and then about 2 miles of water that's about -2 Celsius. So that was somewhat of a sobering experience. But it was cool to see the submarine come up. Okay.
We do have time for questions, so.
All right. Okay. You had your hand up first, ma'am. I'm sorry?
The llama.
The llama.
Oh, the llama. Okay, we'll go back to the llama. I know. You're a perfect straight person. I'll try to do this quickly here. So what my llama is, there is my llama. It's learn, local action, monitor, and advocacy. So learn, and again, this is, I don't need to spend any time about learning to this audience, but when you talk to the Rotary Club, and you talk to people who really they don't know. I mean, it's not sort of the faux denial kind of thing, but they just don't know. The American Association for Advancement of Science has a wonderful, I think it's just 8-page color pamphlet called What We Know. And I tell people, if you read that, you will know more than 90% of the population on climate, and it's AAAS science, it's really, really good. Now, if you want to go to the 98% level, the National Academies has a similar thing. They put out in a joint pub, I think it was a publication 3 years ago with the Royal Society. Some of you might have been even co-authors on that. It's a little bit thicker. It's written in National Academies, sort of, so it doesn't have as catchy a title. But then you're at the 98, 99% level. So I tell people, I'm not trying to turn anyone into Michael Mann, or Gavin Schmidt, or Jim Hansen. You don't need to know that. But if you could read the What You Know for the general public, that's, you're now an informed citizen on climate. That's all I ask on that. The L is local action. And what I tell people is, simply think about your food, energy, and water footprint in your daily life. And what are the things you can do when you have a choice? So this does not mean I'm going to go and sell my house and put a hair shirt on and live in a cave and be miserable. But we all periodically in our lives get choices. And I just use a choice I had. So I moved from Washington to Penn State. And for the given budget we had for a house, I could either have a smaller house close to campus, or I could have a big house, but I would have to drive every day to work. So we chose intentionally the smaller, somewhat older house, but I'm a maybe 15-minute walk from my office, and I don't even have a parking pass, which is wonderful. The university doesn't get money out of me. But I also don't really have a carbon footprint as far as going to and from work. So that was just a choice I could make. We look at, we're converting gradually our lawn and our garden to very low water use, even though we're in Pennsylvania and it's, not that big a deal. Just little things you can do. And we can all do that. I mean, we all, we all have those choices. And again, it's not, live a deprived lifestyle or become a martyr, but just local actions you can do. Monitor is two things. So one for this audience, it's working to make sure that we can do the technical monitoring of the climate. And my guess is most people here know that, while we would love to think it's this robust system that's being exquisitely planned and funded and designed, we know it's shoestring and baling wire, basically, right? We sort of lurch from satellite to satellite. We're never quite sure what's going to get funded. We're never quite sure which instruments NOAA's going to manifest. Is NASA going to drop something? Who's going to pick it up? Maybe the Europeans are going to bail us out this time, maybe not. It's crazy, right? So that's a monitoring. Monitoring is also like monitor what your local and national and state elected officials do and say. What do they say about this issue? Are they saying demonstrably false things? Are they saying nothing? Are they saying constructive things? And then the A is advocacy. And what I mean by that is not, pitchforks and stakes and like burning places down or anything like that, but simply whenever you get a chance to talk to an elected official, what I like to ask her or him is so what are you doing to stabilize the climate? And the reason I ask it that way, I don't ask them, are they for a carbon tax? I don't ask them if they're for cap and trade. Those are yes or no questions. So everybody think back to like dating 101. Don't ask yes or no questions because they're easy to kind of like shoot down. So you ask an open-ended question. You might get an interesting answer. Even if you don't, though, it sort of registers in that reptilian politician brain that one of their bosses, constituents, were interested in this. And if enough people are interested enough, and again, that doesn't mean this has to be the number one issue. That's a really tough ask. But if enough people are interested enough, that will give those elected officials what I would call top cover, some political cover to say, hey, if I talk about this, I'm not going to be fired by my voters. So everybody here heard of a guy named Bob Inglis? Probably a number of you have. Upstate South Carolina, rock solid conservative district, and Bob is, he's got the Bible and he can quote verse, line, and chapter. He was ranking member on the House Science Committee 6 or 7 years ago, and he said, there might be something to this climate thing I think we should investigate. I mean, he was not saying, let's tax everybody. He said there might be something. His primary comes up like in 6 months later, and he went from winning 70% of his district to losing his primary, like that. And, so now he's a climate martyr, and he gets all kinds of awards for being a climate martyr, but he'd really prefer to have his job back. I've talked to him a bunch, and he would really prefer to have his job back. So I sometimes, we sometimes get this thing of, why don't these, they get it. They're not stupid people. By and large, a lot of the center-right politicians get this. Why don't they bring it up? Yeah, they get it. They also get the politics. So I ask sometimes my center-left friends, a show of hands, who wants to be fired on Tuesday? Surprisingly enough, nobody raises their hand. And we've got to, through this advocacy and through other ways, get this away from being a politically very high-risk move for somebody to, come out of the climate closet. We've got to be able to make this a topic that we can have a rational policy debate and not feel like, oh my God, if I bring this up, I'm going to lose my job. So that's it. Learn, local action, monitor, advocacy. That's my llama. Thank you. Ma'am.
I'd like to talk a bit more about framing climate change as a security issue for to engage government voters. And my question is, when Barack Obama says we need to do this security issue throughout federal government, does that help to engage conservative votes in the issue, or does it just reinforce it?
It's a really perceptive question. So I don't know if everybody heard the question, but the question wasn't framing climate as a security issue. And the recent presidential memorandum that came out yesterday, so when Barack Obama phrases this as climate is a security issue, does that encourage bipartisanship, or does it actually encourage, it's like, hey, this is being used as a democratic issue, and it's really political. It's not based on its merits. Is that a fair restatement? So I think it is a really good question. I can tell you my experiences when talking to not all, but many Republicans, is if I'm off camera and off the record, they understand. Almost all of them understand. There's a few who I'm not sure understand. I won't name names, so there's a couple. But most of them really do understand. But they understand the politics for all the reasons we went through. As you get closer to being on the record or in a hearing setting, the pushback you get is a couple things. It's like, well, the president talks about this, but he doesn't actually have any money in his budget to do it, so how serious is he? Which is actually kind of a valid question. And the other part is people sometimes try to play rank the threat. So it's like, and Senator Cruz, if you watch my 3-hour cruise, at the very end, Senator Cruz was trying to press me to say, well, Titley, are you trying to tell me that climate is more important than fighting ISIS? And I would argue that's a false choice. It's a false choice because the inbox will always be filled with crises du jour. Always. Always has, always will. But we do ourselves a grave disservice if we don't look down the horizon at emerging risks, be they demographic, political, economic, or in this case, a risk of the physical environment changing with all the things. So that's a false choice. I think that many people do see this as political, and that's very unfortunate. I hope that things like the National Intelligence Council, which is an apolitical body, They're not appointed by the president. They're really just part of the professional intelligence community, coming out with a report that was also released yesterday. I hope that will help. And again, I think when you're off the record, people do understand that. But on the record, yeah, the rhetoric can get mixed into the politics, and it does. So I've had, you know, a number of people says, yes, Admiral, thank you for your service, but I don't agree with this stuff at all. And that's, you know, so the Republicans are not afraid to push back on military people when they don't believe, or they don't support that policy direction. What else? Sir?
A question about priorities of timescales.
Mm-hmm.
If we had a CNO in this room and we offered him a precise global climate prediction, which I can't do, we offered him a precise global climate prediction 10 years from now, 50 years from now, 100 years from now, but we told him we could only give you one. What would you choose? What, from an operational standpoint, in terms of renewable infrastructure within DoD, what time scale is the most important for those leaders?
So the question, so everyone can hear and make sure I understood the question. If we had senior leadership, let's say the head of the Navy in this room, and we could, in a alternate or in a perfect world, hypothetical world, give a perfect climate projection, but we could only do it for one time scale, be it 10 years, 50 years, 100 years. The question is, which time would that senior leader choose? And I think what they would choose is somewhere between 10 and 30. And the reason, and I'll speak for the Navy mostly on this, and this is why that Earth system prediction capability went out to 30 years. I can sell 30 years in the Pentagon. The Navy has a 30-year shipbuilding program, which the Congress looks at quite closely. We also have a 30-year aircraft building program because the aviators didn't want the ship guys to have all the glory. So we base those on intelligence, threat analyses, and where we kind of see the world going. But there's really very, very little planning done beyond 30 years. And again, the political scientist will tell us it's incredibly hard to get that sort of thing right. I mean, we're dealing with people, and people are trying to deceive us and all this kind of, and we just don't know. So it's probably somewhere in between there. So and I understand fully why, if you were like the chief of naval operations or the head of the Air Force, the head of the Army, you would look for there. I would argue, maybe unsuccessfully, that the Pentagon, at least in their long range, should be looking also at that 50 to 100, at least in there. And I sometimes look even, I would like to look even further. I mean, you know, the things, again, people in here really understand better than me, but, you know, the literature seems to be increasingly showing that when we get to stabilization, even as low as 2 degrees Celsius, you know, we've built in, what, 3, 4, 5 meters of sea level rise, if we, you know, from what we understand today with the Greenland and West Antarctic ice sheets. And if we don't stabilize at 2, even if we do the INDCs out at Paris, we're at what, roughly 3-ish? You know, and then we're talking, what, 5, 6, 7 meters of sea level rise? Nobody's thinking about that. And I know that, you know, that stabilization is probably, what, 2,300, something like that. So I know it's a long ways out. But think about what that means. If we really go down those paths without some sort of climate intervention and decarbonization or negative emissions, that means you need to move almost every coastal city in America, more or less at the same time. I mean, that's going to be a problem so big, and it's going to suck money out of the Department of Defense along with everybody else. So the DoD should at least keep an eye on that, because it's going to be a huge security issue. But to your question, sir, I think it is the tactical guys, the guys wearing uniforms, somewhere between 10 and 30 is probably where they can think of. And of course, so now we get internal variability mixed in with anthropogenic forcing and all that kind of stuff. Sir, and then we'll go here. Okay, 1, 2, and then I'll see how we go.
fairly familiar with some of the adaptation and resilience efforts of the military at the local level. There's Army Corps of Engineers and Civil Corps of Engineers is phenomenal role in terms of adapting communities to some of the projections of sea level rise, et cetera. But how does this how is this affected, I guess, more the high level strategy, the macro level discussions at the higher levels of the military? And will you see that change?
So the question, if I heard it correctly, was at sort of local levels and with organizations such as the U.S. Army Corps and individual communities, there's been some pretty good adaptation and resilience work done. But how are those conversations held at very senior or very strategic levels? Is that a fair restatement? So I've been out of the Navy for 4+ years now. I would be hesitant to say at this point in time how much of that long-term planning is being done. I wouldn't want to say any is being done, but I think much more is sort of in this tactical time frame. And also I think a lot of things, I mean, not to defend the DoD, they're a $600 billion organization, they can defend themselves, but they certainly have been pressurized a lot in the last few years by all the budget constraints, the so-called sequestration, which unfortunately was not carbon sequestration, but dollar sequestration. And that's coming back. I mean, unless the Congress changes the law, they're looking at that square in the face again. The Navy has had huge readiness issues on their new ships, and you have China playing, some pretty dangerous games in the South China Sea. You've got Iran, and now you have the North Korea guy with his nukes. So this is sucking a lot of the oxygen out of the planning atmosphere, if you will. So I think there's not as much as I would argue there should be. If you look at this presidential memorandum, it's kind of an attempt to try to make somebody in charge. It's the old thing, if nobody's, you got to have somebody in charge, otherwise nobody's in charge. So the presidential memorandum basically directs at the assistant secretary level for each agency, somebody's going to be designated to, dot on their forehead and think about this. So I think it's probably not being done that much, but it's, I understand it. I'm not going to condone it, but I do understand why. So I think that's where we are. Ma'am.
I appreciated your highlighting of the Arctic as an area where national security concerns really intersects very well with climate risk, particularly in issues of sovereign territory. Like you gave the example in Svalbard, along with the time to emergence is something that climate research can add value to security understanding. Another good example of where that's likely to happen at some point is access to continental shelves, which interestingly enough have a very large amount of fossil fuel resources and have already been the subject of some significant territorial disputes, which are likely to worsen. So I was wondering if you had any thoughts on how the Navy is preparing for that intersection of territorial and economic disputes, and or maybe if you're an optimist that it will emerge too late for us to really want to get at them.
Yeah. Okay, so if everybody heard that, so we talked a little bit about trying to link the Arctic to some of these either sovereignty issues and sort of the long timelines that happen. But the question is, with the fossil fuel resources in the offshore waters, but in the continental shelves. And you said potential disputes between these exclusive economic zones. How is the Navy preparing? Or alternatively, do we think that maybe by the time we look at this, we'll be kind of beyond fossil fuels, I guess? So, I mean, what I see, maybe it's a little bit of a contrarian view, but there's very little real dispute on the exclusive economic zones. Now, there are conflicting what they call Article 76, which is, so articles, and I know this is where people's eyes roll in the back of the head, especially if you're a physical scientist. It's like, I'm not a lawyer, why should I care? But it's, Article 76 basically gives you, under the law of the sea, the ability to claim far beyond 200 miles. But it's it's based on what they call extended continental shelf. And maybe this is what you're referring to, ma'am. Okay, so these extended continental shelf claims. And you got to do a whole lot of survey work, and it depends on the slope and the geomorphology, and oh my God, I mean, if you're a hydrologist, you love this stuff, though. It's guaranteed work, and it'll put your kids through college. So there have been a number of claims submitted. Russia resubmitted. Denmark submitted. There's at least 2 now claims to the North Pole. And there's a very technical procedures. Actually, the commission, I believe, meets in New York City, if I'm not mistaken, of the UNCLOS. The U.S. Has not submitted. Any idea why? Because we haven't acceded to the treaty. Yeah. So pop quiz, if you ever want to know what the U.S., North Korea, Libya, Syria, Iraq, and Iran all have in common. We are the countries that have not acceded to the law of the sea. It's a great club to be in. But we've done the surveys, believe it or not. We jointly did the surveys with the Canadians. So we had a U.S. U.S. icebreaker, Coast Guard icebreaker, Canadian Coast Guard icebreaker. One would break ice, one would do the survey, and then we'd swap, and we had 100% data transfer between the two, and it actually worked super, super well. I'm not sure we're going to see too much conflict, if you will, over these extended continental shelves. From what I understand from the U.S. Geological Survey, and there may be people in here who have done much more on this than me, but it seems like most of these, I love it, they call them the undiscovered assets, and they're going to tell me where the undiscovered assets are. It's like, well, if you know where they are, how are they? But anyways, I'm just a weather guy. So most of them are within the 200 miles exclusive economic zone, of which there's really basically there was a kind of significant conflict between Russia and Norway. They fixed that a few years ago in the Barents Sea. We have actually a small conflict between Canada, but nobody cares. I mean, State Department and Canadian Foreign Ministry, it's like, hey, when we need to fix it, we'll fix it. But nobody cares up until then. So I'm not sure that that's going to be the issue. I think it is a very interesting issue when you look at where oil prices are. When oil prices are high, everybody wants to go to the Arctic. When oil prices are low, it's like, man, it's expensive, it's hard. The environmentalists kind of like, yes, we kicked them out. It's like, well, no, you didn't really. It's the fact that oil's $40 a barrel and it's no longer economical. It would seem to me, just my personal opinion, that the faster we can decarbonize, that rate of decarbonization, long-term, the less attractive, highly expensive oil looks, highly risky oil looks. But, it's an open question as to, are we going to do that in time? And I don't know. I don't know. I don't think we're going to get a conflict over the Article 76, but I don't know where we're going to go on ultimately, do we or do we not exploit the known fossil fuels up in the Arctic? Sir? One. Okay, all right.
So there was a graph up there that showed fuel mix, and you skipped over in the interest of time.
Yeah.
And you talked about the fuel mix, but another issue there was the growth of energy. Yeah, no, wait, for both of them, really. Another issue is the growth of energy. It's really, a national security risk, and trying to convey that message without sounding anti-capitalist.
Yeah, we're
trying to make it. I'm not trying to tell people to live in the woods.
Yeah. Live in your cave with your hair shirt. Yeah.
Yeah. Is there a good way to say that growth is a national security risk without coming off?
I think one of the ways people are attacking this, and it's kind of through the side door, it's not the direct, it's like, hey, you're using too much energy, stop it, because that's a message that just doesn't sell well. But in very gross caveman terms, we waste roughly a third of our energy, a third of our food, a third of our water. I mean, I'm sure people have better numbers, and it varies by region, it varies by a lot of stuff, but in gross terms, we are not very efficient. So efficiencies are sort of the unsung hero, because every kilowatt hour or calorie or gallon that you save is one less that you need for a population that is both growing and globally more prosperous, right? So you've got the competing part of not only more people, but those more people, as they become more wealthy, want to have a better life. I mean, and given the life that we as Americans lead, it's kind of hard for us to say, no, you shouldn't. That would be like the epitome of hypocrisy. But how do we do this smartly? So is it a combination of efficiencies, of smart grids? How can you bring on renewables at costs that people can afford and then scale them up? How do you get, I think once you get into the area of 50% of intermittent renewables on your grid, you really got to start thinking about, what is your base load, and whether it's storage, big battery storage, some kind of storage, and or some kind of sufficient non-carbon-based base load, which probably would be nuclear, which sometimes is a dirty word for people as well. So I think if you Google CNA, Military Advisory Board, or CNA MAB, and type energy, we actually put out, and I'm on this board, so we put out a report on the security implications of the U.S. electric grid. And basically, it's a grid that was designed over a century ago, and we make the case that this grid is in fact a security threat to, or a security risk to the United States for a whole variety of reasons, one of which is climate. So I think it's an issue. It is there, and it's maybe the way it's being approached is kind of indirect right now, because, I mean, as you mentioned, the very direct approach sometimes can be counterproductive. Thanks.
Thank you so much, Dave, for the wonderful
Okay,
talk.
thanks, Adam.
Coming.
Thank you very much.